Additives are one of the most vital components of a polymeric product. It has played very important role in growth of plastic industry. A typical polymer product contains several types of additives like filler, plasticizer, colorant, stabilizers, and so on. In this video, we will try to explain why additives are used in plastics and also what are the functions of these additives. So let's start with first question, why additives are used in plastic products. We know polymers are formed by joining several monomers like ethylene, propylene, styrene, etc. The monomers in the polymers are mainly connected by carbon-carbon, amide or ester bonds. These bonds are not very strong and in presence of extreme conditions like high temperature, UV light, oxygen or moisture, these can easily break. Also, except thermoset and rubber, majority of the polymers are used in uncross-linked form so that they can be recycled and processed multiple times. Therefore, majority of polymers are inherently weak, which makes them susceptible to degradation under extreme conditions. The first step where polymer experience extreme condition is during extrusion process. Extrusion is performed well above the melting temperature of polymer and at a very high pressure and in air which contains oxidizing agents like oxygen and metal. At such a high temperature and pressure, the bond connecting the monomers are highly susceptible to oxidation by oxygen and metal. And if it is not controlled, polymers can degrade severely, which will make the final product very weak and brittle. Polymeric products also have to go through rough conditions even when they are being used for different applications. Like when products are used for outdoor application, the product can be in direct sunlight which contains UV radiation and also generate high amount of heat. Since both UV light and heat can cause degradation of polymer chain, both of these factors must be taken into account. Different degradation mechanisms of polymeric materials are shown here. We will not discuss these mechanisms in detail, but in general we can say that UV light and moisture leads to degradation of polymeric materials. And as polymers are expected to survive several years in different applications, like in automotive application, polymeric material is expected to retain its mechanical property and appearance for more than 15 years, whereas when polymeric materials are used in buildings, it is expected to survive for more than 50 years. Therefore, if polymeric materials are not protected from harmful effect of heat, UV light and moisture, polymeric materials cannot be used for these applications. And here is the answer to our first question. Not all, but several additives are used to protect the polymeric material from the harmful effect of heat, oxidizing agent, UV light and moisture to retain their physical properties and appearance. And as a certain level of strength and flexibility are required in final product, appropriate additives are used to improve strength and flexibility of the product. So now we can say that additives are used to facilitate processing, achieve desired properties and maintain appearance. Now let's discuss about different additives and their functions in plastic materials. There are several steps in which polymers are converted into different products. Those steps can be represented by two basic steps. In first step, polymers are mixed with additive package. Additive package is the name of the mixture of different additives which are added to plastic to achieve desired performance. Then the mixture of polymer and additive package is extruded to prepare a formulated resin, which is then molded to form desired product. Additional additives can be added during molding process or post-production process. But for simplicity, let's assume that all the additives are added through additive package. Now let's start with the additive used to achieve desired performance in the product and then we will discuss additives for molding and extrusion process too. So first thing that we see in a product is its color. Colorants are one type of additive which are added to achieve desired color. The colorants can be in the form of dye or pigment. Dyes are organic chemical which can absorb light and pigments are particle which can also absorb light of different color. Dyes are used for bright color that faded with time, and pigments are used for long lasting color. So, depending upon the use and need, either dye or pigments are used as colorant to achieve desired color in final product. Now, let's discuss additive used for physical properties, which is probably the most important property of the product. The physical properties basically represents the three different properties of the product. First is impact strength. In case of chair, we can think like this. When we sit on the chair, we are applying an instantaneous load on the chair, so it need to have good impact strength. Impact modifiers are added to achieve desired impact strength. The impact modifiers are mostly functionalized rubber like butadiene rubber, acrylic block copolymer such as SBS, NBR, and EPDM. Second property is tensile strength or internal strength of the material. Again, when we are sitting on a chair, we are applying a constant load on the chair. So, in absence of sufficient strength, the chair will break after some time. Therefore, reinforcing fillers are added to achieve desired strength. Since the strength requirement of household stuff like chair will be less compared to polymeric composites used in car or aeroplane application, so reinforcing agents are also different for these products. When high strength is required, glass fiber, carbon fiber, or Kevlar fibers are used as reinforcing fillers. In case of moderate strength, talc, clay, mica are used as reinforcing filler as well as cost saving filler. Next property is flexibility. Again, when we are sitting on the chair need to have sufficient flexibility, otherwise it will crack like a glass even at slight bending. And also the chair won't be comfortable to sit. So, to achieve desired flexibility, plasticizers are used. Plasticizers are one of the most used additive in plastics, and they vary significantly in terms of their chemical nature and use. So, let's discuss plasticizer in more detail. As I mentioned, plasticizer improve the flexibility and durability of plastics. Plasticizer molecule break intermolecular forces between polymer chains and thus give greater freedom of movement to each molecular chain. Since plasticizers are blended into polymer in large amount, their compatibility with the polymer must be good. Plasticizers can be broadly classified into two main categories: internal and external plasticizers. Internal plasticizers are chemically modified polymers. Basically, these are copolymers of the monomer of the desired polymer and of a polymer with a lower glass transition temperature. The most common monomers which can act as internal plasticizers are vinyl acetate and vinylidene chloride. These plasticizers are limited in use due to their limited availability. Next type of plasticizer is called external plasticizer since these are not connected polymeric chains. This type of plasticizer can be further divided into two categories: primary and secondary plasticizers. Primary plasticizers are chemicals and show significantly high compatibility with polymer resin. As a result, they can be used at a very high loading. Primary plasticizers can provide desired flexibility by itself, whereas secondary plasticizer cannot be used alone since they have limited compatibility with polymer, so cannot be used at very high loading. The most common primary plasticizers are phthalate compound and the secondary plasticizers are silicate polyesters and epoxidized oil. Extendeds are a subset of secondary plasticizers. They are commonly employed with primary plasticizers to reduce cost in general purpose flexible PVC. They are mostly low cost oil having limited compatibility in PVC. They are added to reduce cost and in some cases to improve fire resistance. Example of extendeds include naphthalic hydrocarbon, aliphatic hydrocarbon, chlorinated paraffins and others. Now coming back to the properties of final product. As many plastic products are used outdoor, which means under the sunlight. As sunlight contains high energy UV radiation, it can break the polymer chain and lower the strength and deteriorate the appearance of the product. So to protect the product from the harmful effect of UV light, UV stabilizers are added. There are two types of UV stabilizers: UV absorbers, which preferably absorb UV radiation, and HALs, which quenches the free radical and thus provide indirect protection. As I mentioned previously, depending upon the performance requirement of the final product and environmental condition during use, different additives are added to achieve different performance and also protect the product from the harmful factors. Now let's talk about additives which are used to protect polymer and facilitate molding process. The molding process is one of the process by which formulated resins are converted into different products. Injection molding is one such process. To know more about injection molding, please watch our video on that topic. In injection molding process, molten polymer is pushed inside a mold cavity which is of the shape of the final product. And when the polymer melt cools, product is released from the mold. So the two main requirements during molding process is mold filling and easy release of the product so that product will not have surface defects and also the process can be continuous. To facilitate mold filling, a lubricant is added. This type of lubricant is called internal lubricant because it reduces the friction between the polymer chains and thus facilitate flow of polymer inside the mold cavity. The common example of internal lubricants are fatty esters, EVA, waxes, and oxidized polyethylene. For mold release and surface finish, mold release agents are added. It reduces the adhesion between polymer and mold surface. The common example of mold release agents are silicone oil, graphite, zinc striate, and molybdenum disulfide. Use of these additive helps to improve molding process and also reduces the cost by minimizing the defects and stoppage of the equipment. But the concentration of these additives are very carefully decided since it may cause some negative issues like flashing due to low melt viscosity and also blooming of the additives on the surface of the final product. Next, and actually the first step where the polymers are required to be protected is extrusion. Therefore, some specific additives are added to facilitate the extrusion process and protect the polymer during the harsh conditions of extrusion. During extrusion, there are three main factors which can cause significant degradation of polymer chains. These factors are temperature, oxidizing agent, and friction between the polymer chains and screw elements. For temperature, we cannot do anything except properly controlling temperature so that it should not shoot up from the set value. Because high temperature makes polymer chain more susceptible to oxidizing agent as chemical reaction rate significantly increases at high temperature. Therefore, additives are added to protect the polymer from oxidizing agents. These additives are called processing stabilizers. There are different types of stabilizers like antioxidants, peroxide decomposers, and chelating agents. Antioxidants help to stop degradation caused by thermomechanical or thermooxidative conditions. The way these antioxidants interrupt the degradation process varies according to their structure. Some of the common antioxidants are amine, phenolics, phosphite, and thioesters. These stabilizers are called primary stabilizers. Peroxide decomposers are secondary stabilizers which help to safely decompose peroxide. Peroxides are very dangerous for polymers because radical formation due to decomposition of peroxides are highly energetic and react with other polymer chain to break them into two. And in this process, additional peroxides are formed. As a result, peroxide starts an auto-degradation cycle. Therefore, additives are required to safely decompose peroxide so that it cannot react with polymer chain and create more peroxides. Chelating agents are also added to protect polymer from metals. Some special stabilizers are added for halogenated polymer since their degradation mechanism is somewhat different from the normal polymers. For the third factor, which is friction between polymer and screw, lubricants are added. This time, these lubricants are called external lubricants since these additives reduce the friction between polymer chain and metal surface. The common external lubricants are soap, fatty acids, paraffins, and low molecular weight polyethylene. So, we can see that to facilitate and protect polymer during processing, different types of processing stabilizers and external lubricants are added. Here again, concentration is very important to achieve desired outcome, otherwise the cost and quality of the product can suffer. In addition to additives mentioned previously, some other additives are also added for different purpose, like fillers, flame retardants, nucleating agents, blowing agents, conductive fillers, etc. Many times fillers are added to reduce the cost of the final product, since the cost of some fillers are significantly lower than the base polymer. Other time, filler help to achieve dimensional stability and strength. Some of the common fillers are listed here. Flame retardants reduce the flammability of plastics. They can be divided into inorganic and organic compounds. The most common inorganic flame retardants are aluminum hydroxide, also known as aluminum trihydrate or ATH. Other inorganic and organic flame retardants are listed in the slide. The effectiveness of organic flame retardants like chlorinated and brominated compounds increases with the halogen content. Sometimes a combination of two flame retardants is used to increase their efficiency. Nucleating agents are added to influence the rate of crystallization, mechanical and optical property of the polymers. Some of the common nucleating agents are listed in the slide. To know more about nucleating agents, watch our video on that topic. Blowing agents are chemicals which are used to develop foamed morphology. Isocyanate and water are used as blowing agent for polyurethane, azodicarbonamide for vinyl, hydrazine and other nitrogen-based materials for thermoplastic and elastomeric foams, and sodium bicarbonate for thermoplastic foams. Conductive additives are special additives that help to make plastic thermally or electrically conductive. Some of the common conductive fillers are carbon black, graphite, and metal particles. So, from today's discussion, it is clear now that additives are essential part of polymers. Without these additives, application of polymers can be very limited because these additives are not only helping it to achieve desired performance but also important for long-term use. In absence of additives, polymers do not have required strength and durability to be used in many applications. With that, I would like to end today's video. I hope it will be a useful video for you all.